Good day, learners. My name is Sadiq Dalhatu Jae, standing here to teach mathematics. The topic of discussion today is set theory. First, we are to see the definition of a set. A set is a collection of well-defined objects, things, or numbers. A set is represented by a capital letter. Usually, sets are represented in curly braces. What we mean here, we said a set is a collection of well-defined objects. And learners should take note, a set is represented by a capital letter, and the only acceptable bracket in set is the curly braces. For example, A is a set of all the months in a year. When we said set of all months in a year, learners should know that we refer to as January, February, March, April, May, June, July, August, September, October, November, and December. Now this set A is well defined because all the elements within that set is months of a year. Then set B, set of all the days in a week. All days in a week we refer to as Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Set B is also a well-defined. But once we said set B is a set, we said Monday, Tuesday, Wednesday, then we include a month in set B, then it is not well-defined because a month is included within a day. Therefore, it is not a well-defined. That is why we said a set is a collection of well-defined objects or things. C is a set of all positive integers. All positive integers, 1, 2, 3, 4, 5, 6, and so on. And this set moves to infinity. Now let's see element of a set. We said the elements of a set are the items or things that belongs to the set. They are also called members of a set. Elements of a set are separated by commas. The symbol is used to represent membership of a set, while the other symbol there is used to represent non-membership of a set. For example, let A be a set of 1, 2, 3, 4, and 5. Now looking at this set, the elements or members within set A are 1, 2, 3, 4, and 5. Now we said since 2 is contained in set A, meaning 2 is element in set A, then 2, you can read it as 2 belongs to set A, or 2 is a member of set A, or 2 is an element of set A. Then also 7 is not in set A, meaning 7 is not within set A. Then we said 7 is not an element of set A, or 7 does not belong to set A, or 7 is not a member of set A. Next is the cardinality of a set. The cardinality of a set A is the number of elements in set A. The notation is n, open bracket, capital A, bracket close, that is for set A. If the set is named as X or Y, then the A enclosed in the bracket will change to the given set. Example, Given set P has an element of 5, 6, 7, and 8, then the cardinality of this set P, it means the numbers within, or the members or the element within set P. We have 5, 6, 7, and 8. That is, we have 2 elements within set P. Therefore, the cardinality of set P is 4. That is, numbers of element in P is 4. Learners should take note. If an element of a set is repeated, it is counted once and only once. For example, in set Q, we have element 2, 2, 2 is repeated, 3, 3, 4, and 4. Now the cardinality of this set Q is 2, 3, and 4. 2 is repeated twice, 3 is repeated twice, 4 is also repeated twice. Therefore, this element will be counted once and only once. That is, we have 3 as the cardinality of set Q. Now let's see types of sets. Starting with empty set. A set which does not contain any element is called an empty set. Sometimes it is called void set, and it is also called a null set. Empty set is denoted by the symbol or curly braces without an element within that set. Example, we said a set of human beings with tails. Everyone can believe me that this set must be an empty set. When we say set of human beings with tails, we don't have any human being with tails. Therefore, the set is empty set. B is the singleton set. A set which contains a single element is called a singleton set. For example, A is a set of days beginning with letter M. When we say days beginning with letter M, I think it is only Monday. So therefore, the only element within set A will be Monday. So therefore, it has one element. Therefore, it is what? It is a singleton set. C, finite and infinite sets. A set which consists a definite number of elements is called a finite set. That is to say, if the elements in a set can be counted, then that set is referred to as a finite set. While a set is said to be infinite if the elements within that set are uncountable. That is, we cannot count the exact number of the elements within that set, then that set is referred to as infinite set. Example of finite set, local government in Nigeria. Of course, this is countable. We can count local government in Nigeria. Then, example of infinite set, we said all even numbers. All even numbers, we think of 2, 4, 6, 8, 10, 12, 14, and these even numbers moves on, and it moves to infinity. It has no definite end. So this is an example of infinite set. D is equivalent set. We said equivalent set if the cardinal number of two finite sets are equal, then it is called an equivalent set. Example, a set A has an element A, B, C, and D, while set B has an element E, F, G, and H. Now the elements within set A, we have 4 elements or 4 members of set A. That is A, B, C, and D. Likewise, that of set B, we have E, F, G, and H, 4 elements. Therefore, the cardinal number of set A is 4, and the cardinal number of set B is also 4. Therefore, A and B are equivalent. E is equal set. Two sets P and Q are said to be equal if they have exactly the same elements. Now you take note. Equal set and equivalent set. Equivalent set, the cardinal number are the same. Equal set, it is the elements are the same. Therefore, for example, set P has an element 1, 2, 3, 4, and 5, and set Q has 3, 4, 2, 1, and 5. Observing these two sets carefully, you will see that each and every element in set P is also in set Q. In this regard, the order of arrangement doesn't matter. As long as each and every element in P is in Q, therefore P is equals to Q. Next is a subset. A set A is said to be subset of B if every element of A is also an element of B. Example, let set B be a set with the following elements: 8, 9, 10, 11, and 12. And set A has the element 8, 9, and 10. If you observe, each and every element in set A is also in set B. Is also in set B. Therefore, set A is a subset of B, and this is written as A is a subset of B. Reason A is deduced from set B. Now it says since A does not contain every element of B, then A is a proper subset of B. G, we said disjoint sets. Two sets are disjoint if they have no elements in common. Example, M is a set of elements A, B, and C, and N is another set of elements P, Q, and R. In set M and N, there is no elements that are common. Then M and N are said to be disjoint. That is, their intersection is empty. Their intersection is empty. Next is to see the set operations. Under this set operation, we are to start with union of a set. A union of sets. The union of set A and B is a set containing all elements that are in A or B or both. When listing the union of a set, it will only require combining the element of the two or more sets in one common set without repeating any element. Now, in union of a set, what we are trying to explain here is that for you to show a unionship between sets, it must be two sets or more than two. And when writing out the union of a set, each and every element is listed once and only once, without repetition. For example, we said let A be a set of Y such that 5 is less than or equals to Y, and Y is less than or equals to 10, and Y belongs to set of N, where N is natural numbers. And B is a set of X such that X is less than 7, and X also belongs to a set of N, where N is what? Is a natural numbers. Now we are required to find A union B. Now learners must be able to interpret the statement in set A and the statement in set B before carrying out the operation. In set A, we said A is a set of y such that 5 is less than y and y is less than 10. Here it means the element will start from 5 because it is less than or equals to. That is, the element will start from 5 and it will terminate at 10. That is the boundary, 5 to 10. 5 is included, 10 is also included. But take note, we said a set y is a member or it belongs to set of natural numbers. So therefore our set A will be 5, 6, 7, 8, 9, and 10. That is the interpretation of the statement. Then B is a set of x such that x is less than 7 and x also belongs to a set of natural numbers. Therefore, since it is less than 7, we are going to stop at exactly 6. So the element in set B is 1, 2, 3, 4, 5, and 6. Then A union B, that is what we are going to find, A union B. A union B will be the combination of element in set A and that of A union B is an element is a set of elements 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Next is our intersection of sets. The intersection of two sets, P and Q, written as P intersection Q, is a set that contains all elements common to set P and Q. Example, let P be a set of prime numbers less than 20. Q is a set of positive integers whose squares are less than 20. Find P intersection Q. As I said, when explaining union of a set, learners must be able to interpret this set. For set P, we set of prime numbers less than 20. And set P will have elements 2, 3, 5, 7, 11, 13, 17, and 19. And Q is a set of positive integers whose square are less than 20. Now, learners, you must understand this statement clearly. Positive integers whose squares are less than 20. When you said 1 squared is 1, meaning 1 times 1 is 1. So 1 squared is less than 20. 1 will be within the set. 2 squared is 2 times 2, we have 4. And 4 is less than 20, so will also be an element of set Q. Then 3 times 3 is 9. So 9 is also less than 20, so 3 will also be element of set Q. Then 4 squared is 16, that is 4 times 4. And 16 is less than 20, therefore 4 is also included in set Q. 5, when you said 5 squared is 5 times 5. Now 5 times 5 is 25. And 25 is greater than 20. So therefore 5, 6, 5 and above will not be in set Q. So therefore the only elements or members of set Q will be 1, 2, 3, and 4. Because they are the only numbers that when you take their squares, it will give you a value less than 20. Then P intersection Q. P intersection Q are just elements that you have in set P and you also have in set Q. Looking at set P, we have 2 in set P and we also have 2 in set Q. So therefore, P2 is intersect of 2 in set P is also intersection of 2 in Q. Then we also have 3 in set P and we also have 3 in set Q. So therefore, 2 and 3 are the only elements that appears in set P and also appeared in set Q. Therefore, P intersection Q are set of elements 2 and 3. Next is our complement of a set. The complement of a set R, written as R complement, that is R with a power of C. C is a superscript, or R prime, is the set of all elements in the universal set, but not in set R itself. What we are saying here in general, when you are given a universal set, maybe a set of A, B, C, D, E, and F, then a subset R, A, B, C, and D. What we mean by a complement of a set, these elements are in the universal set, but they are not in set R. That is what we mean by complement. Just a very good example, just take maybe a house with a single room. The house is your universal set. Then you have one room with maybe elements Musa, Isa, and Blessing. Then within that house, we also have Aliyu and Ibrahim. So Aliyu and Ibrahim is the complement of that set, because Aliyu and Ibrahim are within the house but are not in that room. That is what we mean by complement of a set. Therefore, the universal set is a set of A, B, C, D, E, and F. And R is a set of element A, B, C, and D. Upon careful observation, you will see that E and F are in the universal set, but they are not in set R. So therefore, the complement of R is a set of elements E and F. Next is to see the difference of sets. Given any two sets, M and N, the difference between M and N, denoted by M minus N, that is difference, is the set of element in M, but not in N. Similarly, N minus M is a set of element in N, but not in M. For example, if M is a set with the following elements A, B, C, and D, another set N with elements B, D, E, G, and H, then M minus N, that is the difference between M and N, we said is the elements that are in set M but are not in M. If you observe this, you will see that A and C are in set M but are not in set N. Therefore, M minus N is a set of elements A and C, because A and C are in set M but are not in set N. Then N minus M, we said N minus M are sets of elements that are in N but they are not in M. The same thing, if you observe, you will see that E, G, and H are in set M but they are not in set M. Therefore, N minus M is a set of elements E, G, and H. Now, to end the class, I have 3 assignments for you, and please, these assignments are very important. Particularly, question number 3 is a WAEC or SSCE standard. The first question, we said, with 2 appropriate examples, define a set. Question number 2, with 2 examples for each, explain any 5 types of sets. 3, given the universal set X, such that X is a set or belongs to a set of natural numbers, that is N, and X is less than or equals to 15. Then R is another set of X such that X is odd, meaning odd numbers, and 1 is less than or equals to 10. Then P is another set of x such that x is divisible by 3 and x belongs to the universal set, meaning this x is the elements are within the universal set. Find 1 R union P, 2 P intersection R, 3 R complement, 4 P minus R. I will take the question again. 1. With 2 appropriate examples, define a set. 2. With 2 examples for each, explain any 5 types of set. 3. Given the universal set U with element x such that x belongs to a set of natural numbers x less than or equals to 15, R is another set of x such that x is odd, that is odd numbers, 1 less than or equals to 10. And P is a set of x such that x is divisible by 3 and x belongs to the universal set. Find 1 R union P, 2 P intersection R, 3 R complement, 4 P minus R. For any question or further explanation, suggestion or comment, you can contact me on the following numbers: 080 62 26 43 36. The number again: 080 62 26 43 36. And I'm Sadiq Al-Hatujai by name. Thank you for listening.